Okay, so we'll start with the next numerical of linear equation, and in this numerical it's a different type of numerical in which you cannot apply the linear equation, that is v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2s, because in this case my acceleration is not constant, it is going by some other rule, right? Same way velocity is going also by some other rule. So that is why you cannot apply those equations into this. So we have to follow the standard procedure. What is that standard procedure? Maybe we can say from first principle. That is, we have to take it by definition. That is, A is equal to dv by dt, or v is equal to ds by dt, or if I have to calculate. So that's how we have to follow. So the benefit of everybody, I'll just read out the numerical. The velocity of a particle moving in a straight line is given by the expression as v is equal to t cube minus t square minus 2ic t plus 2. Okay. The particle is found to be at a distance of 4 meters from station A after 2 seconds. Okay. The particle is found to be at a distance of 4 meters from station A after 2 seconds. Okay. Then determine the acceleration and displacement after 4 seconds. You have to find out the acceleration and displacement after 4 seconds. Okay. Maximum and minimum acceleration. Now one thing comes to my mind, that what do you mean by this maximum and minimum acceleration? Okay. If I see closely to this, see velocity v is equal to t cube minus t square minus twice t plus 2. From this, if I have to calculate acceleration, then what I'll do is I'll say a is equal to dv by dt, and I'll differentiate it. Even though if I differentiate, then it will be thrice t square minus twice t minus 2. Then also for some value of t, acceleration will be something. Then after that it will changes its value as the time will pass. So that's how maybe it is saying maximum or minimum acceleration. We'll see to it what it is. So let us come to the solution of this numerical. This is the solution. In this, v is equal to t cube minus t square minus twice t plus 2. After 4 seconds, A reaches to 4 meters. Okay. And he is asking what is the value of acceleration, what is s after 4 seconds. Okay. So one thing is very clear. For acceleration A, I have to differentiate v. For distance s, I have to integrate v, because I know v is equal to ds by dt, and if I need to calculate s, then I have to integrate v in terms of t. So I'll apply both these concepts. So for v, ds by dt, okay, a dv by dt, 3t square minus twice t minus 2, and at time t is equal to 4 seconds. What is that? T is equal to 4. I'm sorry, it should be 4 only. Huh? I had already done 4. So it has come out 38 meters per second square. Then for distance, you must remember that we have to apply the constant of integration whenever we'll integrate it. So if we apply constant of integration c, then how to calculate the value of c? We'll calculate the value of c by this given condition, that at time t is equal to 2 seconds, the particle A is at 4 meters. So at time t is equal to 2, s is equal to 4, and that value has given me the value of c as 8 by 3. And if it is 8 by 3, so my s is okay. When s is known to me, then if I put t is equal to 4, and I can calculate s is equal to 37.34 meter, right? And for maximum minimum acceleration, what I will do, I'll differentiate this dA by dt and dA by dt, if I do, it is 6t minus 2, put that equal to 0, or t is equal to 1 by 3, right? If I once again differentiate it, that means d2a by dt square is equal to 6. That means it is a positive quantity, right? And 6 being a positive quantity, then what do you mean by this? It means for this value of a, you will get this condition will be for minimum value of acceleration. And what is that minimum value of acceleration? At time t is equal to 1 by 3. So if I put time t is equal to 1 by 3, then minimum value of acceleration will be minus 2.333 meter per second square, right? So initially it will be deceleration, right, for some time, then it will boost up. So this will be your value of minimum acceleration. Then after that it will speed up, right? So this is what the